Okay, everyone. So we're about to jump into straightness tolerance, but before we do, let's talk about a few important terms. Okay, so first off, the actual mating envelope, and we're going to see these again, we'll talk about them again when we do, is a theoretical perfect geometric shape in contact with a feature. So you know how we have that perfect form boundary, which is like this perfect cylinder that contains a cylinder, or some perfect cube that contains a cube, whatever, it's this perfect size. In this case, we have something that has perfect form, still perfectly cylindrical in this case for a cylinder going through it. However, it is the exact size necessary to let this piece push through that hole. So it perfectly taps the top, it's tangent to the top, and it's also tangent to the bottom. Okay, axis is an exactly straight line at the center of our actual mating envelope. So it's the axis of our actual mating envelope. It is not, however, the next thing, which is our derived median line. Derived median line is the actual center point all the way throughout our cylinder, or we can have a derived median surface, which would be all the points in the center of a surface. It's just I go from each point, I take a little cross, I cut it, and I say, okay, what's the middle of this? And that's the little dot there. And I keep on doing that all the way through it as it curves, and I connect all those. So this actually has a position in my feature. It's a real part of my feature. The axis, however, is not the center line of my actual created part. It is the center line in the model or drawing. Last thing is line elements. They're lines in one direction on the surface of the part. So most times you'll be shown what direction you need straightness on, because if I apply straightness to this, it makes sense for me to have straightness in that direction, but not in this direction because it's curved. Okay, so straightness tolerance. We're going to see examples of this in a bit, but today we're going to be just focusing on a lot of terms here. So first off, it specifies how close to perfectly straight the feature must be made. And it can apply to a surface. When it applies to a surface, we just test each line individually. We say, well, if all of them are straight, it's straight. They're not connected, though. There is no connection between them. If one fails, they all fail, and all of them have to pass individually to pass. Now, the elements are checked in a single direction. I don't also go back and check this direction, too. No, I only check in one direction, and that will be specified on your model or by the way you direct your feature control frame. Now, for our feature control frame for straightness, it has a few things in it. First off, it has the straightness symbol. Then it can have the diameter symbol if it's axis straightness, that's controlling the drive median line, or it can not have that if it's on a surface. And then we'll have a tolerance value. And if we're controlling an axis, we can include the max material condition, but only if we are controlling an axis, not if we're controlling a surface. This never, ever includes a datum feature reference. Don't include it. It doesn't go here. It's not what it's meant for. Now, when it's applied to surface elements, there is no material condition modifier, okay? No material condition modifier. You won't see the M modifier. You won't see the L modifier. You're not allowed to use those. Also, in these cases, departure from the max material condition does not increase the form tolerance, and our size variation may actually limit our usable form tolerance, because we have to have that perfect form at the max material condition. And so if I'm almost at perfect form, then my variation is going to be very small up. I might still have some down, but very small up. And since it can't go very far up, well, I'm going to have a much smaller effective form tolerance. Also, our form tolerance is only ever larger than our size tolerance when we have that independency symbol. Normally the form tolerance is smaller. We want to have a larger size tolerance to allow variation that are okay, like that table. We want to just make sure the top surface is flat. But in some cases, we don't mind if the table is wavy. We just want to make sure that it is straight or something else. In that case, we would have to apply the independency symbol. That's that circle with an I in it. So that's it for this time. Next time we'll jump to a few more examples where you actually get to see these being applied to different surfaces. And I hope this helps you. I'll see y'all later. Bye-bye.